Hello everyone, sorry for the wait. Let me introduce us. I am Marco, this is Matteo. You can probably find us somewhere online using these two handles here. We are the authors of Sonic Visions. Sonic Visions is a Krita plugin that is capable of reading image data and generating MIDI events in real time while you are drawing or editing the image. So, first thing one might ask is, why did you do something like this? Who needs this? Well, first of all, we needed something like this. It's meant for our fun, but a more official answer to this is that we as people like to find patterns and connection between things. Our brains are hardwired to do such a thing. And in music, there are patterns that are harmonies, rhythms, melodies. In visual arts, we have shapes, we have colors, we have recurring themes. Sonic Vision tries to be kind of a bridge between these two words. So the core concept, in proper words, is image sonification. Let's start with the concept of sonification alone. Many people like to explore different ways to hear things. There are famous examples of people trying to generate sound based on plants, electrical responses, or human body electrical activity. Also, thunderstorms that have been translated into Irish music, or also going all the way to the Large Hadron Collider's readings plot data that have been turned into a metal song. The other way around is sound visualization. So there are many common ways that day-to-day are used by people working with sound to visualize sound data. Starting from oscilloscopes that let you see the shape of a sound wave, going through spectrograms that represent the frequency distribution in a sound, so they let you understand if a sound is high or low pitched, find harmonics, and so on. Also, MIDI editors or music notations can be considered as kinds of sound visualization technologies, since they give you an intuitive way to understand the overall motion of the music. Then there's glazes. Anyone knows glazes? Have you ever heard how Pac-Man sounds in real life? It's unbelievable. Well, this is a bit borderline, but anyways, we finally got to image sonification. That is the act of rendering images into proper sounds. So there are many examples, and starting from back in 1989 with an Atari program that can be considered the true ancestor to Sonic Visions, which was Kandinsky Music Painter. Going through research, they proposed a very interesting paper where they kind of use image sonification to let visually impaired people hear images. Going through NASA, that rendered to image their Hubble telescope images. They rendered them to sounds to try and spot unseen patterns into galaxies. Then we go to more artistic examples like Pixel Synth or My Paint Improvision, which is the previous iteration of this software, which was hacked straight into My Paint. Let me try and lower the sound a bit. All right. So let's go on. Why did we choose Krita? Well, first of all, if you don't know, Krita, it is a very appreciated and widely used free and open source graphics editing program. One of the main reasons why we choose to go from MyPaint to Krita is its Python plugin API that let us take a different pace than the main applications development cycles in developing our plugins, since we are doing it in our free time. Also, Python was optimal because it provided us a way to have a fast proof of concept of this program. Another nice aspect is Krita's community. It's a huge community with many artists who are already familiar with the software and its functionalities. So it is nice to try and get into that community and have people already ready to use our software. Also, Krita's maturity and features let us concentrate on the sonification things alone, being sure that the graphics editing is already all that everyone needs. Let me point out one thing. Have you noticed the scan line going back and forth in the background? The annoying music and this scan line are a Sonic Vision session of Matteo playing with our logo. So let's dive a bit deeper into the what and how it's happening. We have a global tempo that is controlled by the playback controls, and at each clock time, the image is scanned, and a vertical line is sampled and passed to all the graphic processors that are enabled and configured. Each graphic processor has its own custom logic that is used to detect graphical features in the image data. That is turned into an inner representation, which is then passed to the output modules, who have their own separate configuration logics, and each one tries to render the inner representation to an output MIDI note using some kind of scales or the thing you want it to behave like. So let's take for an example that picture there in the chart. It's very simple. So let's assume the scanline is exactly where shown. At that point, assuming we have a graphics processor that is configured to detect black strokes, we have 3 play points, the top and the bottom of the frame and the line near the peak of the mountain. So these 3 play points will be then passed to the output render module that we say, for example, to be simple, that it's configured to play back a C major scale ranging 2 octaves. That will mean that as an output we get a chord composed of 3 notes, a low E, I guess, a middle B, and a high G note. So in this last chart, we can see the configuration logics of the program. The dotted lines mark elements that are still in active development. So each element in the interface of the program is backed by a configuration middleware class that completely decouples the active logics from the interface configuration values. This lets us handle the storage of the configurations to retrieve the previous session's configuration. Also, this permits us to, has permitted us to implement a remote control application that goes through the network and lets a second computer, completely separated from the one running Krita and drawing, control the audio and the music part of the application. So this lets us have a 2 players experience that hopefully you will see in a moment. Hoping that nothing goes wrong. So now you are seeing on the left side our remote application, and on the right side the Krita, the main Krita window. Here we have the plugin that is running inside Krita, and the clone application is an exact clone of this one. The only thing that changes are the icons, because in here we are using native Krita icons. On the native application we use native Qt icons, but the logics are the same. The two are interconnected, and they should behave exactly the same. I'll start by letting you see a bit more. We have a synth window down here. This is a software synth that is receiving MIDI notes from the graphical window. While you watch this thing happening, I'll try to fix the sound. In the meantime, Matteo goes on with his drawing. Okay. So, what you're hearing right now is the first detector, which is trying to see luma, which is a kind of brightness. It's the human representation of how we perceive brightness, which is not only the brightness control in an HSV color scheme, but it is weighted a little different. But in any ways, it is making sound any stroke that Matteo is drawing, because he is drawing with light colors on a dark background, so that is making every sound go through and reach a polyphonic synthesizer. So each separate stroke is interpreted as a separate sound. We can actually try and tweak the bass sound and have a different scale, make it more strict. Okay, let's say we did a better impression and leave it like this. We tried something a bit too far pushed, since the remote controls are just been released like 3 days ago for this demo. If you use the application only on one computer, it behaves very differently. So, let's conclude our presentation and hope the other things goes a bit, well, better.
Hi everyone. First of all, I apologize for my poor drawing skills. I'm not an actual artist, as you could guess, but we're looking for new artists that might be interested in the project to help us better understand what could be useful or not. And new contributors, since we have many things to do, and starting from bug fixes, as we have been very good in writing bugs, of course, as you could see during the demo, and many features. I'm quickly going through the most important ones, starting by letting the user define their own custom musical scales, or to group those scales of the different renderers. For instance, when the user selects one musical scale from one of the renderers, all the MIDI outputs would play aligned to that scale. Another useful feature could be to introduce scale image layouts. To explain this, let's remember that currently the drawing area is vertically divided in sub-areas, where each sub-area corresponds to a note of the selected musical scale. But we would like to let the user define different mappings between the musical scale and the drawing area. For instance, the drawing area could be horizontally divided, or diagonally divided, or divided into sub-areas of any shapes, like circles or squares, and so on. We also have in mind some features about tempo controls, like a tempo quantization option that would help percussion instruments sound more musical, more close to an actual drum machine. Another feature could be introducing parallel processors that would add simultaneous multiple scan lines running at the same time, but maybe with different tempo settings, that would allow a user to play with weird polyrhythm patterns, for example. Or we also need to optimize some performance. For example, currently the scanline timing is not quite accurate, and it doesn't match the tempo setting very well. Also, the user might like a tap tempo button just to set the BPM settings, for example. We also intend to improve the user experience in general, starting by storing the plugin settings into the Krita project data that would help the user to replay a previous played session. Also, randomizing all the parameters could be useful for the user, especially when he's in need from some new inspiration. And also, another useful feature could be to embed a drawing preview into the remote application. That to avoid using an external tool to connect to the remote desktop where Krita is running. That, as we did during the demo, we used an external tool, but we would like to avoid that. And also, the user might benefit from some preview layers that would enable an overlay over the drawing area, showing the subdivisions of the drawing area that corresponds to the musical scale. And that would help the user to better understand what's going in the background and to foresee somehow how things will sound while drawing. To extend the use cases, we are also thinking into adding some new play mode. One play mode could be a stylophone mode. With that mode, when the sonic vision processor would instantly play while the user is drawing, what the user is drawing, that by reacting to brush stroke events. Another play mode could be reacting to MIDI inputs that could be useful to tweak the parameters via control change events, or to select the root note of the musical scale, or drawing the MIDI notes that are being played by an external MIDI instrument. And that's it for the features. These are all tracked to our GitHub project page. And I hope you found these interesting. We are here for questions, and thank you.